So I'm Vignesh, and I'm from recent graduate from Dayanand Sagar College, 2025 pass out. So I've recently completed my internship at Texas Instruments for 6 months in the domain analog layout. So during my internship, I've worked on all analog layout basics and all the projects related to analog layout. And
Which college? Which college you
Dayanand
have
Sagar,
mentioned? Okay, okay. Where it is?
it is near Kumaraswamy layout in Bangalore.
Okay, okay.
So in during my internship, taught me all the from basics till advanced analog layout concepts related to analog layout, complete from flow of analog layout. After the training, they gave me a project related to analog layout. So I worked with the design team for the layout point of view. I worked on the project. There was one major project given to me, which I had to complete during my internship period. So I had completed that project during my internship, and then I was looking out for opportunities.
Okay, so which projects you have done?
I've worked on in layout. I have worked on Stop LDO project. So Stop LDO is the one project where it basically works. The
Yeah,
application is
actually,
uh,
wait. You are giving the design verification. Yeah,
hmm.
right. So,
So it's
what
related
projects you
to
have done in
yeah.
design verification?
So in design verification, I have done one vending machine using FSM. It's basically uh, the vending machine basically works like if you put a coin. So we had like three coins, 1 rupee, 2 rupee, and then 3 rupee coin. So using FSM, we had designed that vending machine. So using Verilog, first we had designed it. So with the help of that uh, the application, right? So basically 1 rupee, 2 rupee, and 3 rupee. So I had designed the Verilog code in such a way that if you put a 1 rupee coin, uh,
Okay.
so so I'll just let you know. Uh, so basically, I had worked on the Moore FSM model for this vending machine. So basically, I had like 2-bit 00 no coin, 01 5 rupee coin, and 10 is like 10 rupee coin, and unused is 11. So based on these four like states, I had designed this Verilog code. So this was one major project which I had done. So dispense pulse for dispensing item, and then amount is like current collected amount in cents, like in the rupees. So I designed in more FSM such that S0 state is 0 rupees, S1 state is 5 rupees, S2 state is 10 rupees, and then more than that is it is like ready to dispense. So I had designed in such a way that this was the project for this. Like I had designed one Verilog code and wrote an FSM code for this.
Okay, so what states you have mentioned in your project? What
Uh,
FSM states?
like I had like four states, like more, I had used more type of FSM.
Okay, what is the difference between the Moore and Mealy?
Cadence.
Sorry.
What is the difference between the Moore and Mealy?
So more FSM is basically the output depends on the present state only. And in the Melee, present state plus inputs. Like the output in the Moore machine, the only on state transitions, it's synchronous with clock. Whereas in Melee machine, it can change immediately with the input. It is like asynchronous. So in Moore, the main difference is like output is stable between clock edges in the Moore machine. And in the
Okay,
Melee,
but
the
you have mentioned like it is like the synchronous or asynchronous. What do you say?
yeah, for in the Moore machine, only on state transitions. It can like only on the clock edge the output changes. Whereas in Melee, it can change immediately with
No,
the
you have
input.
mentioned about the synchronous and asynchronous thing.
Yes.
So, what is
Synchronous in the
more?
sense like it can change like only on the state transitions, like only on the clock edges. Asynchronous to clock means it can change immediately with the input.
Okay, so you know about the synchronous and asynchronous reset. thing
Yes.
also.
Uh,
What is difference between them?
Synchronous and okay. Synchronous reset. Okay. So basically, this synchronous reset, uh,
You
if the
can share
reset
your
happens,
screen. Yes,
okay.
you can share your screen to like show me or
Okay.
explain to.
Like I'm recalling it, so that's why. Like the synchronous reset, like it changes only on the clock edge, and asynchronous reset, it is like immediately when the reset is asserted. So the flip flop, suppose the flip flop is there, so the flip flop resets only when the clock edge occurs. Like reset is synchronized with the
In
clock.
asynchronous.
In synchronous, the
Okay.
output resets only when the clock edge occurs. So the it requires the clock to be running for the reset to take place.
So how we can write equation? Like can you
Okay.
show me in the always block?
Okay. So always at positive edge clock, this represents the synchronous reset. If we want like asynchronous, we usually put or pause edge reset.
Okay. So what it mean?
So basically, this pause edge clock is the like only on the like rise or fall of the clock, the output changes. Whereas for the reset, right, or positive edge reset, so it changes immediately when the input also changes. So it does not like depend directly on the output, on the input. So it does not like in asynchronous, it does not depend on the rise or fall of the clock. It changes immediately. Whereas in synchronous, it waits for the clock, like rise or fall of the clock. During that period of time, it changes.
Fine. So you know how to generate. But what do you mean by the sequence detector? First, tell me this.
Okay, sequence detector, like if we have suppose 101 or like we have like three states. So we usually perform like this state machines. So 101. So if we have like S naught state, so this sequence, if we have like one, there is a zero input incoming. So that stays in the same state itself. If there is any one input coming to the state, it goes to the next state. So whereas in the S1 state, again it will see for the 0 or 1. So the
Okay.
output is one only when the sequence is detected 101. So the output remains 0 till the sequence is not detected. So the output is 1 only when the sequence is complete 101 or 100, like that.
Okay. So can you design a sequence detector of 10010 with overlapping condition?
Okay. Shall I take my book and
But
right? I'll just take my book and I'll just do it.
you can open the EDA playground or any other simulator
You
in
just want
which you
that
simulate.
FSM this thing, right?
Yes. You can show me. You can write a code on it, and I can see
Okay.
from here. Sequence detector 10010 in More. Okay.
Okay. 10010, is it? Okay. I'll just type the code here.
Overlapping. Yes, you can write it here also or in any simulator also.
Okay. Overlapping, right?
Yes,
Okay.
overlapping.
Okay. Is this fine?
Are you saying something?
Sorry.
Are you saying something?
No, no.
Okay.
Is the code fine or do I have to change something?
That can you explain me?
Yeah. So basically, we are setting parameters S0, S1, S2, S3, and S4, S4,
What is the
S5.
difference between the parameter and local param? Why you
Uh,
have used the local parameter, not
uh,
parameter?
like for declaring the state machines, we usually declare it with local parameters.
But why we have not used the parameter? Parameter function is also like resolved, right? We,
Para, like
uh,
uh, like you're saying, like why not only parameter, right?
why you have not used the parameter and why you use instead of parameter local param?
So like before, while writing code, right, before and all, like I was using this local parameter for like declaring for the state machines.
But why we have used like
Oh,
we know the function of parameter.
yeah. This parameter is like it's like declaring a constant from like how do I say it, from outside the model during instantiation. So this local parameter, I think it's that cannot be like instantiated, like overridden.
uh,
That's the
Yes,
difference, I think.
it can be, cannot be overridden.
Sorry.
Local param. Yes, local param cannot be overridden.
So yeah, like it is local to the module itself.
Yes, yes, continue.
So yeah, after that we are declaring the states, state and next state. We are storing it, registering it, and at the positive edge clock we begin like if the statement if it is reset, it is on the S naught state. Else, if it is not reset, we'll go to the next state, and we begin the states all with the case statement, and we it loops like it continues. So S naught we go to the next state and this input is S1 and S0 and
So
if
what operator is this? Uh,
conditional.
but conditional are like if else statements also you have not used instead of you use this statement.
Sorry, I'm not able to hear properly. Huh?
I'm saying that conditional are also the if and else statements, right?
Hmm, hmm, hmm.
But you have used this question mark statement, what we call it.
Like this case statement we can like easily be like for all the states, right? S1 to S5. We'll be
No,
able to,
I'm talking about the operator.
okay. Like we are using if this is the case, then S1, otherwise S0. Like that
Yes,
is the,
ternary operator is yes, ternary operator.
huh, huh.
Yeah, that's what I
Okay.
was
Yeah,
asking.
conditional is correct. Yeah, ternary. Right.
Okay.
So this follows that this thing ternary operator. If the input the S1 is input, then it is go D in, then it is goes for S1, otherwise for S0. It for all the five states it follows the same. Then it comes like default is next state, S0 state, and we end the case. We end case statement, and we again begin this positive edge clock begin. If the reset is one, the output is zero. Otherwise, if the reset is active, the output is zero. Else, the state is SY.
So, okay, fine. So, do you know about the large inference and combinational logic?
Sorry, not able to hear properly.
Do you know about the large inference in
Latches,
large inference in
huh.
combinational logic?
Latch inference in combinational.
Yes,
Okay, let me think.
yeah, you can take some time.
Yeah, So latch is like basically a, which does not have any clock, and it remains on till the enable is like one. In the like flip flop is the one which the output is dependent only on the rise and fall edge of the clock. So when you mean the combinational inference, uh, how do I say? When I'll just write one sample code, let me know if this is correct.
Yes, yes, you can.
Suppose when there is a select one, if the select line is one, so the output is A. Otherwise, the output is not assigned any like value to it. So there's a level sensitive triggered, we say, for the latch. Like to remember the previous value, the latch is used. Like the latch is inferred.
I cannot able to understand what are you saying.
Like it's a level sensitive logic, right? So
Okay.
yeah, so when there is the output is one, when the enable is one, the latch is the latch output is continuously on when there is enable is one. While as in flip-flop, right, there is when there is only rising and falling of the clock edge, the output changes. Whereas the output remains on till the enable is on in the case of latch, is what I'm
Yes.
trying to say.
Yeah, and you have made the right example, but we have not explained that if I don't use the else statement,
Mm-hmm.
then the problem is there. Then the latch will infer.
Correct.
So that's what the main reason.
Okay.
Because if we miss any statement or any block,
Mm-hmm.
so it will not does not assign a value to an output in
Output.
all
Correct. Yeah.
possible
So the
conditions.
missing else statement is the main cause of this latch inference.
Yes, yes, we have to include all the possible conditions. If we don't
Conditions.
include, it
Hmm.
will give or the inferred. It will not give it will give the error of inferred latch. The
Infer latch.
warning we have the inferred latch. If you have done any example in Verilog code in which you have not mentioned one of the statements
Hmm.
of a possible statement, then you will notice this input latch problem.
Correct. Yes. Got it.
Okay. So, what do you mean by the universal gate and why we call it universal?
The universal gate is NAND and NOR. So like any gates can be constructed using NAND and NOR. So using NAND gate, we can construct OR gate, AND gate, and NOT gate. And even using NOR gate, we can construct all these gates. That's why they are called as universal gates.
Okay. We can create any of them.
Sorry?
So we can like create any of the gates using these two gates.
Oh, yes, yes.
Okay. So, what is the use of what can we implement any gates using the 2:1 mux?
Any gate using 2:1 mux. Okay. Uh,
Can you show me like implementation of the AND gate using the 2:1 mux?
And gate using toast one. Let me just think. Shall I write it in a book and then shall I show it?
Yes, yes, you can.
Yeah. Okay.
After
Just
like solving it, you can show me.
sure. Just a second. I'll just get my book.
Yes. I think you are muted if you are saying something. You are muted.
I'm writing in a book.
Okay, okay. Okay, okay, fine. You have to implement and NOR gate using the toast one.
Okay. Just trying it out. Like I don't know if it is correct or
Okay.
like I'm trying to write a truth table for it. Like based on that, I try to draw a circuit of it.
Yes, yes. That's the correct approach.
So I'm not like looking anywhere. I was just writing in a
What are you saying?
like I told, I was writing in a book. I was not looking anywhere. I just
Yeah, I know, I know. I was saying that that was the correct approach that you are
yeah,
drawing the truth
yeah,
table first.
yeah.
Yes,
Like
yes.
I just wanted to confirm like I was not anywhere looking at. That's it.
Yeah, yeah, I know. Okay.
Should I write some Verilog code for it or just other this thing?
No, just you have to like implement.
Okay. So for 2:1 marks, like there'll be like two inputs and one select line, two
Yes.
inputs A and B, and one select line S not. So basically, when there is one select line, just a second, one output. So like when A is equal to 0, um, the output should be 0.
Yes.
When A equal to 1, the output should be B. Is that correct? Like when A equal to 1, the output should be B. Like there are D not equal to 0 and D1 equal to B. The output selected will be
No, no.
0,
Can you like explain it like what inputs you have given? A and B.
A and B. Yeah.
Okay, so you have picked the select line.
Yes, select line. One select line.
Okay. Or you continue. Can you explain like from the starting?
When okay, when there is S not equal to 0,
Yes.
the output is 0. And when
Okay.
S not equal to 1, the output is B.
Okay. Okay.
That is the logic. I'll just try for NOR gate.
So basically, you have fixed the input 0. Like
Hmm, hmm,
instead of
hmm.
A, you have fixed
Correct.
the 0.
Yes, yes.
Yeah, actually, you have to like tell this that you have
Okay.
fixed.
Okay.
Okay.
I'll
So
try
for
for
the OR gate,
hmm. For OR gate, put output will be B. When the input is 0, And when the output
Okay.
is when the input is 1, when A is equal to 0, output is B. When A equal to 1, output is 1.
Oh, so what input you have fixed here?
0
No, I'm talking about the input.
input, like it depends, right? Like oh, you're talking about the select line.
No, I'm talking about the A and B input.
Okay. No, like I thought like when A is equal to 0, the output will be B.
Okay.
When A equal to 1, the output will be 1. Like that I recalled it.
Okay, okay. So basically you have fixed the input 1 to 1.
Hmm.
Okay, fine. So can we make the XOR gate also?
XOR using 2:1.
Yes.
Okay, I'll just try it. Using XOR, when A equal to 0, the output should be 0. Mm, 0 XOR B, which gives B as the output. When A equal to 0, output is B. When A equal to 1, it will be 1 XOR B.
So what will be, can you draw the diagram and like show me?
Yeah, I think I'll just explain it. Uh,
No,
when
for
A
XOR. What will be the diagram?
for
Yes.
XOR,
Yes.
yeah, A bar B plus AB bar. Like this is the XOR.
No,
The
no.
upper one is
Yeah. Okay. Yeah.
so the
For
upper one
the
have drawn using 2:1 marks. So the
okay.
inputs what I have given is when A equal to 0, so it will be 0 XOR B. So the output will be B. When A equal to 1, it will be 1 XOR B that will become B bar. Is that correct or something have missing?
Actually, maybe you have to put a NOT gate between the two inputs, between the I0 and I1.
Oh, between the two inputs, one NOT gate, is it?
Yes.
Okay.
Like we will have the same A input
Hmm.
in the both the I0 and I1, but
Hmm.
they will be like between the NOT gate.
Okay.
Have you understood?
Yes, yes.
Okay. So you know about the duality theorem?
Duality, duality theorem. I've heard of it, but I'll just try to recall. Just like it's something like replacing and with or like or and or with and. like dual this thing, right?
Yeah. Yes. Yes.
Correct?
Yes. Yes.
Okay.
So, what is the master slave in JK flip-flop?
What are the problems?
What are the master and slave in JK flip-flop?
Master and slave. Okay. Uh, so in JK flip-flop, there is a race around condition which is happening. So for that, we go for the master slave flip-flop to avoid
And
that
what is the race around condition?
race around condition. Yeah. So the race
Yes.
around condition is when the inputs of JK flip-flop are both are one. So it keeps on toggling 0 and 1, 0 and 1, 0 1. It is not stable. So that is the race around condition. To avoid that condition itself, we go for master slave. Correct?
What are the master slave? Can you like explain me that how they function?
Master, like what is master and slave?
Yes. How they
Okay.
function exactly?
Like it is two JK flip-flop, like two latches, a master and followed by a slave. Uh, it's like it is master is constructed by cascading two latches, like kind of slave latch. The output changes only on the like triggering edge of the clock. Like basic idea is like the master latch is triggered by the clock and slave is like triggered by the clock bar, like inverted of that. So only like one latch is on at a time. Like that is like when the master is on, the slave is closed and the master holds data and then slave yeah, that is one thing which I was in the positive edge of the clock, the master is like transparent and prevents the race around condition. So that is what I know about the master slave.
Yeah, fine. Okay. Um,
Hello,
Bistable element. Do you know about the bistable element?
bistable multivibrator,
Bistable element.
bistable element. Okay, I just got it. Like it is a circuit that has uh, like two stable states and can store like one bit of information. Like it remains in one of the two states like until an like input triggers.
Can you
That
show the diagram?
diagram. Just a second.
How they look like basic bistable element, how it look like.
Okay. Like this. It's like the flip-flop or the latch. Like the output is connected to the one input and this NOR gate output is like connected to the input.
So what are the operational amplifiers?
Operational amplifiers are the one where it amplifies the magnitude of the input voltage. So suppose there is a magnitude of V, the operational amplifier performs many of mathematical operations, such as addition, subtraction, multiplication. So adder, subtractor. So basically, it amplitudes the input voltage. So suppose there is a V, the output will be multiplied by 2V. So it has like
Okay.
various performs basic mathematical operations.
Okay. So, like, I'm giving you one question. You have to write, I'm giving you it orally, and you have to write it in the notepad. Okay.
Oh, okay.
Um, So, the number of essential prime implicants,
Just a second. Number of.
essential prime implicants
Okay.
for the function y is equal to
The function y equal to
A complement, B complement, C complement D,
a complement, b complement, c.
C complement and D
Okay.
plus A complement, B, C and D complement.
A complement, b, c complement, and
No, C is not complement, D complement then.
okay.
Yes, 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 yes. And then there is a complement in C and D. A and
Plus
B are normal. Uh, Plus, yes,
a,
A and
b,
B
c
normal.
complement, d complement.
Yes, yes, right. We have to
Okay.
solve it.
Or using K-map.
Yeah,
So for like a bar, b bar, c bar, d. Uh, how do you like represent it in form of like numbers? Like uh, it, if A bar, B bar, C bar, D is there, it will be like 0, 0, 0, 1, correct?
A bar, C bar, D, 0001. Yes, correct.
Yeah. So
Yes,
yeah, that will be one. And A bar, B, A bar, B, C, D bar is 0, 1, 1, 0. So 0, 1, 1, 0, that will
yes,
be
correct.
6.
Yes,
Okay. And then A, B, C bar, D bar. 1, 1, 0, 0.
yes,
Okay. That will be 1. Rest all is 0, correct?
yes.
Okay.
It's all not zero actually. The high points are these only.
Sorry.
I'm saying rest of all are not zero actually. We cannot say
Okay.
like this.
Yeah, like
Um,
don't care condition comes right.
no, no, no. They are not. There is no don't care condition. Only these three terms are high in the
High,
K-map.
correct. Hmm. Correct.
There are blank.
So they can be X or 0, correct?
Yes, yes.
Hmm. So what I need to find out here? Uh, like I've written down the K-map like this.
Uh, Can you like open that notepad?
Okay.
Why we written these zeros in the
Yeah,
question?
that is like X or 0. That I thought like it is all 0. So
So you in the question it is written that you have to find out the essential prime implicants.
hmm. Okay.
You know about the essential prime implicants
Yeah, I'm
and
trying to recall about that. Actually, prime implicants and essential prime implicants. Yeah. Uh, can you just give a hint on it?
yeah, essential prime implicants are the group of ones which are not paired. Any at least one pair,
Okay.
one in a
Correct.
group is not paired
Hmm.
to any another group.
Okay. So there are like three essential prime implicants.
Yes, yes,
Okay. Like all are single, they are not paired.
yes. So there will be three.
Yeah, three.
So you have done the internship in Texas, right?
Yeah. Yes.
So how you get that internship?
So that was through college placements. So that was actually supposed to be internship plus replacement offer. But due to this market, this thing, there are no openings in my team actually. So that's why that was the problem which had
So you have
occurred.
worked in analog part there.
Yeah, I had like they had hired me for analog layout itself. Like they had come to my college for to hire only analog layout. Like TI comes for our college only to hire for that role itself. Sometimes it comes for embedded, but it usually comes for analog itself.
Okay. So what syllabus was there
In
for the
analog layout.
interview? No, no.
For the
What
interview
they
of
have
TI.
asked, yes, yes, what they have asked you.
So basically, they had asked me about first there was like assessment. First round of this thing was assessment, all aptitude, digital, analog, all mix. Post
Oh,
that, yeah, after that getting shortlisted, we had interview of around half an hour to 45 minutes. So it was all about basically analog itself, basically network theory, KVL, KCL, and then theorems, all network theorems. Then some digital questions, like which is like basic digital questions. And based on resume, it was like more of about to explain about my projects which I had done. And apart from that, they explained me the role, what they are offering, and yeah, that's it.
okay. So like you, in the next problem, you have to reduce the function.
Hmm. Just a second.
Why is the function of A, B, and C?
Reduce the function.
Yes. Why is the function of A, B, and C?
Y is the function of A, B, C.
Yes. And it is equal to the sigma 0, 1, 3, 6, and 7.
It is equal to just a second.
Sigma
One,
sign. Sigma sign.
just searching it. Just tell me 1357, right?
0, 1, 3,
Okay.
6, and 7.
Okay. It is all min terms,
Yes, yes,
like using K-map only.
yes.
Okay. Three variable K-map, correct?
Yeah,
Okay.
correct.
So it is A bar, B bar plus BC plus AB. There are like three pairs.
Can you repeat?
A bar, B bar
Okay,
plus BC
okay.
plus AB.
Well, um, it's incorrect. There will be like two terms only.
Like, I'll just show. Think it's not visible.
So, you know about the wire and reg in Verilog?
Wire and red. Yeah.
What
To
is the
store the
difference
in,
between the two?
what I know is the it is to for input we write it as wire to store the bit to store the input, and reg is like storing the output. For input we use wire, for output we use reg, wire and register.
Not a generalized, but it's not generalized basically.
Okay.
So what are the default values for wire and reg?
Default. Uh, Is it like 0 and 1?
No, no. You know about the value set in Verilog?
Value set.
Yes. Means how many values can be possible in Verilog?
16 bit, like
No,
0 to
basically zero,
255.
1, and X and Z we can have the value set.
Correct. Yeah. 0, 1, exact. Yeah. 0, 1, don't care. And then Z is the default one, is it?
No, no. Basically, X is not the don't care and Z is not the default value.
Okay. Okay.
Basically, X defines the unknown value and
Unknown.
is the high impedance state.
High impedance.
So,
Correct. Yeah.
so basically, by default will be Z because if no current will be flow, then it will be in high impedance state.
Hmm.
So the default value will be Z
Hmm.
for the wire, and for the reg it will be X because the
Okay.
unknown value we can have, because reg is basically to hold the values, right? So
Hmm.
we can have 0 or 1
Hmm.
there. So we don't know, so we write X, the unknown value.
Okay.
Okay, so do you know
Hmm.
about the um, types of nets?
Right. So next.
Net, like
Yeah.
supply 1, supply 0, something.
Sorry. I did not get.
I mean that supply 1, supply 0 thing. You know about that?
Apply one. I've heard about it. Like I
Okay.
detailedly, I don't like know about it.
Okay, so basically in Texas, you have not used very long.
No, there, no, I've not used very long.
So what basically you have built and in
I've
what
like
which project you have done the
there I
project?
have worked on completely layout. So like layout in the sense from the basics of all the layout techniques which had to be implemented from the layout flow, basically floor planning, placement, routing, and then
Okay,
EM.
so, so basically, you have worked on any live project?
Yeah, live project. Yeah,
Okay, which type of project? Like,
it was a LDO project. It was a technology was 65 nanometer technology. It's a TI specific
okay,
technology. So that was a real-time live project. So that my block was assigned was LDO block. There was some more LDO blocks on the top level, which has to be connected to this block. So there, like it's a complete IP. So there are more IPs on top of this IP. So I had assigned this one block, and there were many blocks assigned to many other like members of the team. So I had assigned this one block, and I had to align with the design team regarding all the constraints related to layout and everything. And I had to do EM run, which is technology specific, because I had my one current specific element. So that's why I had to do EM run and everything. And that was like a month, like 2 months or 2 months project it was.
okay. Yes.
Like I had designed like two projects they had assigned me. One I had completed earlier, so they gave me one more project which was like half completed by them. So I had to done only EM for that, and there were a lot of design changes happening for my first project. So
Okay.
so the design team had given me one more like he after the design changes he gave me the block again. So I had to rework on that again. So that was the one thing. And during my college days, I had like worked on this Verilog and this thing. So I was like looking out for DV also, with some basic knowledge of this Verilog and then other things. Yeah.
Yes. So basically, you know about the case X, case Z, or case statements.
Case statement. Like using the
There
like
are
how we wrote for Verilog.
three
Uh,
types of like case and case X, case Z.
that yeah, I've heard about it. Yeah.
Can you like explain me?
Uh, Case Z is also a high impedance case statement, correct? Or is it different from the
So basically, I don't think you know about it very much.
yeah, like have heard but not very have not able to recall it about it actually.
But, so you know about the non-blocking and blocking element
Yeah, blocking is like used
statements.
for blocking statements are used for like combinational logic with equal to symbol. And for sequential, we use non-blocking statements like less than or equal to store the previous inputs and the current state. So
Okay.
basically, in combinational, we use the blocking statements, and then in sequential, we use the non-blocking statements.
Okay, so I'm giving you one a portion in the chat box. You have to like just copy it and paste it in your notepad, and
Okay,
have to give the output of this question.
okay.
What will be the output? And basically, you have to. This is the whole code, and you have to give what the display statement will display on the console.
Okay.
Can you copy it on your notepad?
Yeah.
Yeah. Thank you.
So decimal 1 is equal to 2, 4-bit 4-bit decimal 1111, is it?
Yes, yes.
Okay. Just a second, I'll just try to solve it.
Okay.
So this basically A is one is immediately assigned to two, like A is immediately assigned to B in blocking part, and like B is like 5. So the current value of B becomes 2 now when it is here. So A becomes 2, correct?
Okay.
So B, after that, B is immediately assigned to 5, updated to like 5.
Okay.
So the output will be A equal to 2 and B equal to 5 in blocking.
Okay. Fine. It's correct.
Okay. And then in the non-blocking part, A equal to B equal to 4 by D2. Okay. A will be 1, B equal to B will be 2. Okay. And then A is updated to 2 again and B is updated to 5. So here also the A will be equal to 2 and B equal to 5. Like
Okay.
the value of B is like sampled before before B itself is updated to this part. So the A will be equal to 2 and B equal to 5.
Okay. For the non-blocking part also.
Yeah.
Okay. Then. Yeah, I think that's all for today.
Okay.
Yeah. Do you have any doubt for me
Like
or
can I know
any other questions?
what will be the like what is the feedback like how well was like
I think you have to work on the Verilog part, and
hmm,
I think you have worked on analog, right? So you
hmm, hmm,
don't have much knowledge in Verilog part. So
hmm,
in
hmm.
next interview, I will like go in the deep because I have not asked much Verilog questions
Okay.
because I think you have to work on. So I will ask
Okay.
in the next interview.
Okay.
Yeah.
Yeah.
Okay. Any
Mm.
other questions?
Yeah, nothing.
Okay.
Yeah. So when
Thank
can
you.
the next interview be scheduled?
It can be on the next week.
Okay.
Mm.
Thank you.
Thank you.